For our second last question, we see that Miriam is selling school spirit decals, and she had to pay a total of $50 in advertising costs, and each decal cost her 25 cents in materials. But she's able to sell the decals for $1.50 each, and we want to know how many she'll need to sell in order to break even. And that means in order for the amount of money she takes in, her revenue, to equal the amount of money she spent, her cost. Well, what we're going to do is we're going to let D be the number of decals sold. Well, she makes $1.50 for every decal she sold, and she spent 25 cents in materials per decal, and she spent a total of $50 on advertising. And so what that means is if the amount of money she takes in can equal the amount of money she spent, then we'll have answered the question. And so we simply set them equal to each other. 1.50D is equal to 0.25D plus 50. We have one equation with one unknown. And the last one is kind of a toughie. We've got Tommy rollerblading 100 meters against the wind, and it takes him 20 seconds. He then rollerblades, we're missing the word rollerblades, he rollerblades 100 meters with the wind at his back, and it takes him 4 seconds. And we want to know how fast Tommy rollerblades and how fast the wind is. And in order to answer this, it's helpful to picture, imagine rollerblading and the wind is at your back. It's helping you. It's really easy and you're going really fast. But then imagine you turn around and the wind is against you. Well, it would be kind of difficult. And so you'd go a lot slower. So what we're going to do in this question, first of all, is we're going to remember, we're going to want to have R represent Tommy's rollerblading speed and W representing the wind's speed. Okay? And then we're going to try to remember this. Tommy, when he is rollerblading and the wind is helping him, there's an additive effect. He's rollerblading at a certain speed, the wind is pushing him along at a certain speed. You can add them together, and that's how fast Tommy's going all together. But then, when he turns around and he's going against the speed of the wind, then whatever he's rollerblading, let's say he's rollerblading 8 meters per second, if the wind is going 6 meters per second totally against him, he's really only going to be moving at 2 meters per second. What we do in that case is subtract. Okay? So, when the wind is helping him, his total speed is his ability plus the wind, R plus W. And when the wind is against him, when it's hurting him, then his total speed altogether is his speed alone minus the wind, R minus W. Okay? And so we have to keep that in mind. We've got two different possible speeds. And also, what we have to keep in mind is that the time is going to equal the distance over the speed. So, when Tommy has the wind blowing at him and it's slowing him down, he goes a total of 100 meters at a speed of R minus W, and it takes him a grand total of 20 seconds. But when Tommy has the wind helping him, he goes a lot quicker. It only takes him 4 seconds instead of 20. And that's because he goes 100 meters and he's going at a much faster pace at R plus W. Well, what we can then do to make these equations is to say, let's multiply both sides by R plus W, and let's multiply both these sides by R minus W. So what we would have is 100 equals 20 times R minus W, and then distributing in the 20 would give us this equation. And then we could look at the second relation and say, multiplying both sides by R plus W, we would have 100 equals 4 times R plus W. And distributing in the 4 would give us this. And so what we have are two equations in terms of R and W. We have a system of equations.